Hello and welcome to this presentation and demonstration of an IoT system based upon Raspberry Pi. And I am your presenter, Khurram Beg. Through this presentation and demonstration, in introduction part, we will be looking at our system sketches, how the system is designed. Then in methods, we will be looking into materials and methods used to develop the system. And in demonstration, we will be talking about results which we have achieved out of these systems and analysis of these results. And at the end, we will be discussing an important part of any IoT system, which is cybersecurity. So, in there are two parts of this IoT system. In one, which we are acquiring data from an alarm system and storing this to ThinkSpeak and MongoDB. There is an alarm system based on Raspberry Pi, GPIO, temperature sensor, which communicates over I2C, acknowledge button, indication, LED, and buzzer. Whenever alarm goes to a certain above certain temperature, it will generate an alarm on buzzer, and the LED will start blinking. And when we'll acknowledge this alarm with our push switch, then buzzer will go off, but LED will still be blinking as the alarm is still on. Then we will be storing our temperature sensor data to ThinkSpeak and into MongoDB, which is MongoDB is a database which allows us to store data in form of collections and documents. We are accessing our Raspberry Pi operating system through our Windows PC over remote connection RDP or XRDP in Raspberry Pi. And all this alarm system is programmed or developed in Python script using Tony Python. And then we will demonstrate how we can retrieve our data from MongoDB into by using Python script. And for this, we are using Spider in our Windows PC. Also, graphical user interface of MongoDB can be used in our local PC, which is called MongoDB Compass. Then in MQTT, part of this system. By the way, MQTT is message queuing telemetry transport, and this protocol is used in IoT application to acquire data from sensor. This is a publisher and subscriber model protocol in which publisher publishes data and subscriber subscribes to data. He used this data, and in between these two, publisher and subscriber, there is a MQTT broker. In our case, it is HiveMQ Cloud, and we are going to acquire data from alarm system, from temperature sensor, and Raspberry Pi will publish this data, and Windows PC will subscribe to this data through this MQTT broker. And also we will demonstrate that data can be subscribed also through MQTT-X desktop client. So materials and software used are these. Worthy to mention that Adafruit T-Cobbler Plus is very useful. It is it provides you your GPIO pins from Raspberry Pi to your breadboard. Softwares, Windows operating system, Raspberry Pi, Tony, Python tool, and Spider Python in Windows OS, MongoDB Compass, MongoDB Atlas, HiveMQ Cloud, MQTT Broker, and ThinkSpeak. Here is our Raspberry Pi. There is a Raspberry Pi kit, Model 3 B+, and Adafruit decoupler, very useful. It will make your GPIOs available to breadboard, and you can make your circuit very easily. It is highly recommended. This is our temperature sensor, AM2320, communicates over I2C. Our buzzer switch, acknowledge switch, and LED. And our Raspberry Pi is connected to power through micro USB port. Here is the video demonstration of Raspberry Pi alarm system. As I explained earlier, it starts giving alarm above certain temperature, and it can be acknowledged using acknowledge button. LED is blinking, alarm is on, and we can acknowledge this alarm using this button. A little bit about ThingSpeak, MongoDB, and MQTT Broker. ThingSpeak IoT service, it can be a channel can be set up in ThingSpeak. After setting up your account, then you'll use your channel ID and write API to write your data to IoT server or field. We are writing our remote temperature to our ThingSpeak field. Then MongoDB Atlas. There is a cluster on MongoDB Atlas, and in this cluster, a database is initialized, temperature DB, and it has 2 collections. And each collection will insert our documents through Python code. Here is the MongoDB Compass locally install graphic user interface, and when we'll enter our credentials from MongoDB Atlas into this and connect it, so all of our databases would be available in this local MongoDB Compass. And we can also use our MongoDB Compass with the local MongoDB server or cloud, just we have used in this IoT system. And in MQTT broker part, we are using this MQ Cloud as our MQTT broker. Here are the credentials, cluster URL, and pod we will be using in our Python scripts to publish data over it and subscribe through it. And also these credentials we will be using into MQTT-X desktop client. Here we have configured this MQTT desktop client using MQTT these URLs, and I've done subscribe to a topic in MQTT desktop client, which is sensor temperature AM2320. This same topic will be used in Python script to publish data. Demonstration of our system. Here, if we look into our alarm system and storing temperature data to ThingSpeak, and MongoDB. So I've used these standard libraries, ThingSpeak, PyMongo, and Adafruit AM2320 for sensor, and Pod. Here there is a setup of MongoDB, same URL, credentials, and this is our temperature DB and our collection temperature. Here is the setup for ThingSpeak. Then we are acquiring the data from our sensor. Here we are initializing communication. Low pass filter, and here we are requiring the temperature. Implementing low pass filter, and then this is alarm system code, how it will behave. Alarm system will behave. Formatting the data, putting into a document. And here we are writing our data to ThingSpeak and MongoDB. Let us run this script. So I've got alarm, and I can acknowledge it, and let us look to our ThingSpeak channel. Here we are writing to ThingSpeak, and here is our MongoDB database. Here are our latest entries. And also we can retrieve our data, for example, which is stored into MongoDB using Python script. Here I'm accessing and printing first 12, for example, data fields to chart. It can be stored and used in analysis purpose and other purposes in our program. Then there is MQTT. Publisher code. It is using for MQTT library. And here is the definition of where we are defining our broker address, username, and the credentials. And here is our topic, which we are going to publish to. Here are connecting and messaging functions, initialization of communication to our MQTT broker, and then we are acquiring our data from the sensor and then publishing it. Let's run this. Here, this is Raspberry Pi operating system. And then we are going to look into our PC and try to run this code, which will subscribe and store the data. Connected successfully and subscribing to this data. It writes after every 3 seconds. And we can also subscribe to from our MQTTX client. So this was a demonstration of the system. At the end, we'll talk about the cybersecurity aspect of our system, which is, of course, the main ingredient of any IoT application. So Raspberry Pi as itself is a secure operating system, relatively secure OS than Windows, but it is highly recommended that change the password on your Raspberry Pi in order to have a better security. Use encrypted security protocol to access Raspberry Pi over network. Like I'm accessing my Raspberry Pi from my PC through RDP protocol. And when it comes to ThingSpeak, so it uses standard security protocols, and also it has authentication mechanisms like RIDE API and channel ID. Um, and MQTT uses TLS and SSL security protocols for secure communication. And if you are working on some commercial project or even some hobby project, so it is highly recommended that you use firewall between publisher, subscriber, and MQTT broker to have a better cybersecurity in your IoT system. Thank you.